Let's say I gave you this circuit and I said, can you tell me what the equivalent of this circuit? Tell me R equivalent. And what you have, we call that a bridge here. You have something that looks like this. Now I'll put some numbers here. 1, 2, 3, 4, and 5. And I say, what's the equivalent of that? What's our equivalent? Well, good luck to all of us, including me. How do you find our equivalent? These two are not in parallel. They're not in series. What are you going to do? These two are not in parallel, not in series either. So I can't combine them. I'm stuck. What I'm looking at, this picture here, and that looks like a delta. Maybe I can convert that to a y, and that's what this one is telling us. Maybe that'll make it easy. So how do we go from delta to a y? How do you go from something like this? If you have a delta, we'll call it like this: R1, R2, and R3. How can I take this and convert that to a Y connection? Let me call them, here we go. Let me call this Rx, Ry, and Rz. Can I take that delta and change it to a y, this upside down y? Because I can make my delta, because why they call it y, so it's not a y, but I can reverse that and make it look like this. Right? And now when you replace it with the y, that replace it with something like this. That's why it's called the y. See, that looks like the letter y, capital Y. How do we go from delta to y? Well, the way we do them, you look at the resistor, for example. You want to find what R sub x is? Here's R sub x. That's the top one, this one. The bottom is always going to be the same. It's the sum of all three of them. For R sub y, the bottom is going to be the same. R1 plus R2 plus R3. And Rz, the bottom is going to be the same. R1 plus R2 plus R sub 3. Well, how do you find R sub x then? What's the top? Let me take a look at R sub x. This is the easiest way to remember that. So you go in here from delta to y. Delta to y. Notice R sub x is this resistor. Look at the two adjacent to R sub x. What are they? 1 and 2. So the top is going to be R1 times R sub 2. R sub y, that's this resistor. What are the two adjacent resistors to it? R1, R sub 3. And look at R sub z. The two adjacents are what? R2, R sub 3. That's how we find the equivalent for each one. Now, if you're lucky, these values are equal, because if they are equal, once you find one of them, it's the same thing for the rest of them. You only got to do it once, but it's not that complicated to do it. I mean, it doesn't take that long. And the other one, if you have y and you want to change it to a delta, you want to be able to go back and forth. So this is from y to delta. So you have a resistor like this. we'll call it, I don't know, r sub x, r sub y, r sub z. And you want to convert that to a delta. Delta will be like this. R1, R2, R3. Now, for this, the top is going to be the same for all of them. So R sub 1, the top is going to be R1 times R sub 2, or I use X and Y, I'm sorry, X and Y. It's going to be Rx times R sub Y plus R sub Y times R sub Z plus R sub X times R sub Z. This times this plus this times this plus this times this. The top for all of them. Rx, Ry plus Ry, Rz plus Rx, Rz. And R sub 3, same thing, the top is always the same. So basically what I did, I started this times this, plus this times this, plus this times that. Now what's going to go on the bottom? Looking at my picture, this is my R sub 1. What is the resistor opposite to R sub 1? Rx, that's the bottom. R sub 2, what is R sub 2? This one. What is the resistor opposite to R sub 2? Ry. And now I'm looking for R sub 3. What's the resistor opposite to R sub 3? R sub Z. Again, let's take this example I had up there, and I says, I have no idea how to do it. And now see what can we do with it. I want to find our equivalent for this. So here's the problem again, one more time. Yeah. No? Okay. Here's the problem one more time. 1 ohm, 4 ohm, 3 ohms, 5 and 2. And I'm looking for our equivalent. Looking that way. What I could do, I can take this one now. This is a delta. See it? And replace it with an equivalent Y. The equivalent Y will look like this. So my circuit will look, after I do the conversion, it will look like this. And now instead of having this, it will have this. And if I know these three numbers, I'm done, because I can combine these into one, then parallel, take the result, add it to this. How would I find what that value? I'm going to give them numbers. 2, 3, this is a 5, right? So let's say I want to call this R1. R1 is going to be what? The product of the two adjacent, which is 3 times 5. Over the sum of all three. 2 plus 3 plus 5. That's a 10. 15 over 10, which is what? 1.5? This one is going to be what's called R sub 2. Is going to be the product 3 times 2, which is what? 6 over 10, which is what? 0.6. And R sub 3 down here in the bottom, the product of these two. What's 2 times 5? 10 over the sum of them, which is 10, that's 1. Now my circuit look like this. I have 1.6 here in parallel with what? 5.5. I don't have to make it like the way it looked there. With 1 down here. Because this piece here in parallel with that. The product over the sum again here. What is 1.6 times 5.5 over the sum of them? Divided by 1.6 plus 5.5. 1.24. And the 1 here. And what's our equivalent now? 2.24 ohm. Without that conversion, I'll be in trouble there. Try to find what R equivalent is. The only other way to do it, if I didn't have that, is really to apply a source here, like 5 volts or 1 volt, and calculate the current. Go V over I will give me that. But that's more work. Again, I could have took the top one and made that, because that's also a delta. I could have converted that one to a Y. Let's try another one. Do we have time? Yeah, we have time. Let's try another one to find our equivalent. It's a big one here, lots of pieces to it. Five, 6, 4, 7, 10, 3, 9, 20, 6, and 12. And I'm looking for R looking that way. What is R equivalent? Look in that direction. can do quickly combine these two guys together first thing first, just to shrink it. And that would be what? 18 parallel with 20, right? So what's 18 times 20 divided by what? 38. 9.47. Should we double check that?
No, he's right.
So I can replace all of this here so far. That's the first part. So maybe I'll do that. Instead of the 20 here, that's 9.47. 10, 3, 7, and maybe what I should do here, take this delta. Would that help me if I replace that with this equivalent? Let's see what will happen. If I did that, I'll have this resistor here, this one here, this one here, and the 9 here. And if I know what these numbers are, I'm in good shape. This one is going to be 5 times 4 divided by the sum of them. So the top, our top, 5 times 4, which is 20, over the sum of 5, 4, and 6, which is what, 15? What's that, 1.33? The one on the right, 4 times 6, 24 over 15. What's 24 divided by 15? 1.6. And the left, 5 times 6, which is what? 30 divided by 15, which is 2. Let me clean it one more time. I can take the 2 and 9, make it what, 11? $1.6 and 2 and 9, which is what? 11. 3, 7, 9.47, and I got what, that 10 ohm here? Did I leave anything out?
Can you make another delta?
Where? Where you?
11, 1.6.
Yes. This one. There's another y to delta, or delta to y. Right? So I can replace this, this, and that with the red ones. So let's see what you're going to have. Now, what was that's 1.6, and this is, okay. So we're going to replace that with this value, that value, and this value. And from here, there's another 10 going up. $9.47. If I can find these values here, so this is what I'm replacing. I'm replacing this one here. I'll circle it. I'm replacing these 3 black resistors with the red one. The value of this one is going to be the product of these over the sum of them. The sum is what? This is 11. 11 and 3 is what? 14, 15.6. So this resistor is going to be, what we say the sum? What was it? 15.6? It'll be 3 times 1.6 over 15.6. 0.307. How about 0.31? This one here is going to be the product of these two, which is 11 times 1.6 over 15.6. $1.13. The bottom one is going to be the product of these two, 3 times 11 over 15.6. $2.11 or 12. 2.12. If we clean that, we're making progress. Here we go. We have 7 on the top, and we have what? 10.31, 1.33 and 1.13, 2.46 is it? Notice again, there's another delta here, see it? Or I can take this y here and make it a delta. Maybe I'll do y to delta here, just to be different. So maybe I'll do that. I'm going to replace it with this, this, and that. So these 3 resistors will disappear, get replaced with this. Or I could have took the delta and made it y, probably same thing, less work for me, but the top is going to be the same for all of them. Here we go. I'm going to replace it here with 1 resistor. We'll get the value of that. If I get these 3 numbers, I'm in good shape. The top for all of them, the top is going to be what? 10.31 times 2.12 plus 2.12 times 2.46 plus 2.46 times 10.31. This times this, plus this times this, plus this times that. Let's see what the top is. $10.31 times 2.12 plus 2.12 times 2.46 plus 2.46 times 10.31. The top is 52.435. So this resistor here is going to be this number divided by 2.12. The opposite. So 52.435 divided by 2.12. 24.7. This resistor here is going to be the sum here divided by that resistor, 2.46. 21.3. And this resistor is going to be what?
Divided by 10.31.
Yep, 52.435 divided by 10.31. 5.1. Notice these two in parallel, the product over the sum. Seven times 24.7 divided by the sum, which is what, 31.7? 5.45. $21.3, 9.47, 5.1. Now we're making progress. These two, you can see they're in parallel. Product over the sum. 9.47 times 21.3 divided by the sum of them. $6.56. $5.45. 5.1, we're looking for R in that direction. These two are what? In series, that'll be 12.01, is it?
Yep.
And finally, this will be one resistor in parallel, and it's the product over the sum. 5.1 times 12.01 divided by 17.11, right? 3.58, is it? That's the equivalent of that circuit. But if I don't have the Y to delta or delta to Y, good luck. Good luck.